Okay, today I'm going to perform experiment 14A, the sulfur clock reaction. Be sure that you open up the Google Docs that's provided for you on Google Classroom and follow along with this video and the experiment. The goal of the experiment today is to determine the rate law for the overall reaction and the order of the reaction with respect to the concentrations of each reactant. The reaction that we'll use today is between sodium thiosulfate, hydrochloric acid producing solid sulfur, sulfur dioxide, water, and sodium chloride. The way we'll measure the rate is by determining the amount of sulfur, the solid sulfur made until the reaction solution becomes too turbid to see through. How we'll determine that is we'll mark an X on our paper. We'll mix the reactants together in the different proportions. We'll look down the reaction vessel, and the time when we can't see, we'll mark the time it takes until we can't see the X any longer. You can see I'm going to perform 6 trials. Trial 1, 2, and 3, I'm going to vary the amounts of sodium thiosulfate. Trials 4, 5, and 6, I'm going to vary the amount of hydrochloric acid. Follow along on your lab data. There's more details about what's in each reaction vessel. I need to add water so that the total amount of drops in each reaction are constant. And you'll, in your analysis, will calculate the concentrations as they varied in each trial. Follow along on that.
Okay, this is trial 1, where we had 30 drops of sodium thiosulfate and 20 drops of hydrochloric acid. I've added the sodium thiosulfate. We'll start the timer when we added our first drops of 3 molar hydrochloric acid. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You can start to see the sulfur being produced as this reaction solution becomes cloudy. We'll stop it when we cannot see this X any longer. And now, 37.69 seconds for trial 1. Trial 2, we have 15 drops of sodium thiosulfate, 15 drops of water, and 20 drops of hydrochloric acid. I've added the sodium thiosulfate and water to the vessel. I'll again start the timer when I first add the first drop of hydrochloric acid. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Speed this one up. You can see it is having an effect on the rate. Changing the concentration of sodium thiosulfate seems to be slowing the reaction down. It's taking longer to make the same amount of sulfur. We're now at 55 seconds. Again, we stop the timer when we can no longer see the X through the solution. And now, 1 minute, 12 seconds, 0.23 seconds. Trial 2, trial 3, 10 drops of sodium thiosulfate, 20 drops of water in the vessel now. I'll start the timer when I add the first drop of hydrochloric acid. 18, 19, 20, 20, 20, 20. Now we're decreasing the concentration of sodium thiosulfate and it seems to be slowing the reaction down, so we expect a longer amount of time to produce the same amount of sulfur in this reaction. And there it is. We can no longer see it. 2 minutes and 4 seconds. It in fact has slowed the reaction down. So here comes the results of trial 1, 2, and 3. We decreased the concentration. Here's trial 4. 30 drops of hydrochloric acid, 20 drops of sodium thiosulfate. I've added the hydrochloric acid, so I'll start when I add the first drops of sodium thiosulfate. And there it is. 1 minute, 3 seconds, 0.15.
Okay, now that we've collected the data for experiment 14A, it's time to do the analysis. Our first analysis is going to be to calculate the concentrations of our solutions in each trial. We're going to use our beloved M1V1 M2V2 equation. Note the concentrations of our hydrochloric acid and sodium thiosulfate. And our drops, we can use volumes and drops because they're canceled out each time. And our total volume in each trial was 50 drops. We're then to calculate the rate. The rate is going to be just simply the inverse of the time it took to produce a turbid solution that we couldn't see through any longer. 1 over time. 1 equals the amount of sulfur that we made each time. And the time was obviously time elapsed. Easy calculation. 1 over time. Now we're going to determine the order of the reaction. We can determine the order 2 ways, graphically or using the equation. The first way would be graphically. We can see that we'll make a graph of concentration versus the rate, if you can read that. If it's 0 order, changing concentration will have no effect on the rate. First order, we double concentration, we double rate, so we get a linear graph. And second order is we double concentration, we quadruple rate, so we get an exponential graph. Graphically, it's, of course, all of this, we only have 6 trials, 3 trials for each reactant, so we're going to try each way to determine the order of the reaction. We can also determine, using our equation, the change in the concentration to the x equals the change in rate. So, for example, we choose 2 trials. I would choose the larger concentration for the numerator. For example, concentration in trial 1 over concentration in trial 2 raised to the x equals rate trial 1 over rate trial 2. X is our order. We should be able to determine the concentration, the order of the reaction using both those methods. The other problems, we simply, to find K, we plug in, we choose a trial, plug in all the values except for K, solve for K, don't forget those units. And then the last one deals with just plugging in the concentrations to some random concentrations using our rate constant and finding a rate at those new concentrations. Good luck. Hope this helps.